So at this stage in our studies of finance and financial math, we make a bit of a pivot to go over some material involving regression. And this is done at this stage where we've just finished Markowitz portfolio optimization, because it really is an opportune time. And when we think about Markowitz portfolio optimization, we made this idea of plotting portfolios in risk reward space. And so any portfolio that was a mixture of our N risky assets appears in this space. And we noted that when we look at the risk minimized portfolios, only consisting of the N risky assets, and we selected any expected return mu for our portfolio, that risk minimization resulted in us moving as leftward as possible in this space for any given mu. That results in this efficient frontier on which we invest. We then introduced the idea of the risk-free rate, so our money market account that paid risk-free rate mu sub f, and we noticed that if we took this point on the horizontal axis, because that represents a risk-free, or standard deviation being 0, rate of return mu f, and we formed the line that connects this point to the efficient frontier in such a way that the line is tangent to that portfolio, right on the efficient frontier, say here, which we call the tangency portfolio. We then noted that any point on this line segment, between this point representing the risk-free bank account, the money market account, and the tangency portfolio, represented a investment that mixed the tangency portfolio and the risk-free rate, the money market account. And we noticed that this actually gave us a leftward shift from our efficient frontier, just by including that risk-free asset. And we also noticed that if we can actually go beyond the tangency portfolio on this line, which represents shorting the money market account or taking a loan and investing the proceeds in the tangency portfolio. So as we move along this line, this ray, we are increasing our leverage as we move to the right. And this line is what we will call the CML, or the capital market line. And this is where we get into the transition from Markowitz's work in the 50s to Sharpe's work in the 60s. And Sharpe worked with Markowitz, and Sharpe completely builds his model, which is the famous capital asset pricing model, which we will study in detail. It's completely built on this framework of efficient investing. And so we need everything that we built here to actually study CAPM properly. It is 100% built on this framework and the assumptions underneath this Markowitz framework. Now, it's also important to recognize that once we get into CAPM, even though it is built on Markowitz, it actually will have in its interpretation a very natural approach that involves linear regression. But it's important for us to recognize that regression will give us an implementation of this model and also a statistical interpretation of this model. But the model is not built on regression. The model is built on this Markowitz framework. But if you were to take a course in a business school setting or an economics setting where you don't have to know some vector calculus, some convex optimization, calculus-based probability and statistics. Without that heavy mathematical background that we needed to understand this Markowitz portfolio selection framework, this CAPM material is often presented as a regression model, because some basic regression is really all you need to understand that alternative interpretation, that alternative framework, or that alternative lens through which you can view CAPM. So we need some regression tools to understand how regression becomes a part of the capital asset pricing model as we begin to extend it from this Markowitz framework. So this is a natural time in our studies of efficient portfolio theory to take a pause and learn some basic regression material, because it is going to be interwoven with our study of CAPM. But it is very important to recognize that CAPM is built on this material that we've already learned, and regression is going to come into the mix. But it's also the case that people with business or economics training will have never seen this Markowitz side of thing in terms of the math. They will understand CAPM through the language of regression. And so in order to talk with people and communicate with people who have a more traditional business and economics training, this is the language that you really have to know, because that's the language they will speak. To understand basic linear regression, you don't necessarily need all of this. And so traditional business and economics or finance training will train people in basic regression, but not in vector calculus, convex optimization, or calculus-based probability. So we need some regression now, and we will take some time to do that and then pivot back to the study of Sharpe in the 60s that builds on Markowitz. And again, CAPM really develops all of the tools that are the foundations of what you would call modern day portfolio analysis. So people who have the type of job with a title like financial analyst are using the tools from CAPM, often with this regression type of terminology and technology.